So we'll start with a circle. It's a white circle. Start with a circle. A tangent line is any line that hits a circle at one point. So a tangent line never goes inside of a circle. All right? So a couple different things we can do with tangent lines. If tangent lines have a common endpoint, see how these two tangent lines share this one endpoint right here? So one thing we can justify is that this length and this length are the same size. All right? Two tangent lines that share a common endpoint are equidistant from the outside of the circle. That's kind of a basic one. Another thing we'll do is we'll look at a tangent line as it connects to a radius. So if the center of the circle is right here, and there's a radius, a tangent line always creates 90 degrees with the radius. So that gives us the ability to draw a line from here to here, and it becomes a right triangle. That's something we just left working with. So tangent lines, tangent lines, tangent lines all day today. So let's fill in the blanks here. A blank line is a line in the plane of a circle that intersects the circle at exactly one point. A tangent line. So a tangent line is a line that intersects a circle at exactly one point. The point P, or the point where the circle and the tangent line intersect, is the is the radius. So this point right here, that is always going to be the radius. So the point from the center of the circle to where the tangent line meets the circle is always the radius. Now, the radius and the tangent line are always perpendicular. Always. Every time, all the time. That is one of the primary properties of a tangent line. Are you going to... Did he not? Alright, so for our first theorem, it says if a line is tangent to a circle, then the line is blank to the radius at the point of tangency. If AC is tangent to circle O, then OB and AC are what? If they create 90, So if this line is tangent to the circle, then the line is blank to the radius. The black line is what to the radius? Perpendicular. So one thing we're trying to remember here is that the radius and the tangent line are always perpendicular. So if I drew another tangent line from here to here, and then I connected the center of the circle to this tangent, what do I know about this angle right here? This is perpendicular. Every tangent and every radius are perpendicular at the point of tangency. So another concept we're going to talk about is this piece and this piece are equal to each other because they have a common endpoint. What do you know about this radius and this radius? Can the radius be different sizes? No, so the radiuses are equal too, so it creates a kite. Remember kites back in the day? So it creates a kite. Now, the last one that we've been kind of talking about, if two tangent segments of a circle share a common endpoint outside the circle, then those two tangent segments are... What do you say about the blue lines there? The blue lines are equal, so if I have two tangent lines that share a common endpoint B, those two tangent lines are equal to each other or are congruent. So two main things. Tangent lines and radiuses are always perpendicular, and if two tangent lines share a common endpoint outside the circle, then those two segments are congruent. So now it's kind of remembering what's going on and putting that into practice. So think about something that we talked about is, do we have a way to find x here? What do you know about those two blue lines? They are congruent because they share a common endpoint outside the circle. So you should write the expression that 6x squared is equal to 12x. Now we have to solve that. What is x? Huh? Okay, I can divide both sides by 6. What else can you do? How do you get x by itself? Could I divide both sides by x? So x squared divided by x is x. 2x divided by x is 2. So I could have divided both sides by 6x. Now we can check it, make sure it works. 2 squared is 4, and 6 times 4 is 24. If x is 2, 12 times 2 is 24. So both blue segments are 24 units away from the side of the circle. Ooh, pretty. What's the concept here? What do we know about the term x divided by 4 and x minus 6.3? They're equal to each other. So because these two lines are both tangent to the green circle and share a common endpoint, those two blue lines are equal. So x divided by 4 is equal to x minus 6.3. And it's our job to get x by itself. So what would you do? How would you start this? I would multiply both sides by 4 to get rid of the denominator. So these 4's cancel and you get x equals 4x minus, let's see, 6.3 times 4. So x equals 4x minus 25.2. Something you should be a little more comfortable with solving. Move all the x's to the same side. Minus 4x on both sides. Negative 3x is equal to negative 25.2. Now you get x by itself. Did y'all get stupid over spring break or what? Oh, stupider, sorry. Divide both sides by negative 3. Welcome back to math. So negative 25.2 divided by 3 is 8.4. I did that in my head. So if you have a phone on your desk, which I'm sure most of you do, you can double check my math. You can just trust me. Yeah? So this is all theorem 12.3 using those distances from the outside of the circle. Oh, here we go. This is a good one. Now, is this the same thing we were just doing? No. Look, blue line, they touch the outside of the circle, right? Is this the same thing? Do both lines touch the outside of the circle? This line does. 9. This line right here is called a secant. It goes from this endpoint inside the circle. So lines outside the circle are tangent lines. Lines inside the circle are secant lines. Now, let me erase and minimize distractions here. What do you see there? What is that? It's just a right triangle. So you have a right triangle, you have a squared plus b squared equals c squared. So if I'm using this as my right triangle, A, B, and C, the hypotenuse. So this whole length is x plus 6. So if I'm going to solve for x, I have to use Pythagorean Theorem. A squared plus b squared equals c squared. A squared plus b squared equals c squared. Yes. Please, please, please be careful. It is a squared plus b squared equals c squared, not x squared plus 6 squared. It's the whole thing squared. So x times x is x squared. 9 times 9 is 81. But x plus 6 times x plus 6. That's where you have to do a little bit of foiling. Most of you guys learn to multiply x plus 6 times x plus 6 like that. So x times x is x squared. X times 6, positive 6x. 6 times x is positive 6x. 6 times 6 is positive 36. When you combine like terms, that's what you get when you multiply out x plus 6 times x plus 6. I know you've done that before. I like to show you my way. Are you cool with that? So I know that's what you learned in Algebra 1. I think it's great, but I think I have a better way. So let me erase this, or I'll leave it there and I'll show you my way over here. I like to do it like 2-digit multiplication. Alright? 6 times 6, positive 36. 6 times x, positive 6x. Okay, placeholder. X times 6, positive 6x. X times x, x squared. So now everything kind of falls down. You get x squared plus 12x plus 36. I like doing that better. It makes everything all organized and pretty. Does that kind of make sense? So that's better than first, inner, outer, last. It's 6 of one, half dozen of another. Either way, we're left with x squared plus 12x plus 36. Now here's where you guys freak out. Like you don't know how to solve that, do you? Something really, really great happens. Both sides have an x squared, right? So I can subtract x squared from both sides. And they cancel. So you're left with 81 equals 12x plus 6, 36. Which is not bad. Now it's kind of a 1-step, 2-step deal. Move all your numbers to the same side and divide by the number next to the coefficient. So 81, 12x, and 36. We need to subtract 36 from both sides. Which gives you 45. Pretty sure. Is it 45? So 81 minus 36 is 45. 36 cancel, and you're left with 12x. Now we have to divide both sides by 12. Which is 3.75. Allow me to get my calculator. Baker reaches for cell phone for YouTube video people. Calculator. 45 divided by 12. 3.75. Nailed it. All right. Glorious, huh? So much math. What? What? What is 3.75? So all this, what is 3.75? X, right? Now, what else could you call 3.75? Yes. The radius is 3.75. Now, after all of that work to find x is 3.75, what else can I do to ruin your day? Hey, what's the area of that circle? Hey, what's the circumference of that circle? Hey, what is the arc length described? Ooh, what's the diameter of that circle? All this fun stuff I can throw at you after all that math just to find the radius. Am I going to do that? Yeah, just find x. I'm being nice. Oh, that looks familiar. Try it again. We know the process. Now let's just practice the process. We're trying to find x, aka the radius of the circle. I'm not asking you for diameter. I'm not asking you for area. I'm not asking you for arc length. I'm not asking you for a sector. I'm just asking for x. What is x? How big is this angle right here? 90 degrees. Now I have a right triangle. So I can do a squared plus b squared equals c squared. Training wheels off. X times x. X squared. 12 times 12. 144. I'll give you a little bit of time to answer this one. X plus 8 times x plus 8. Here's how I do it. Eight times 8. Yes. 8 times x. This is positive 64. 8 times x is positive 8x. Placeholder. 8 times x. X times x. Everything falls down. So you get x squared plus 16x plus 64. There is a time in your life where you'll be expected to do that mentally, aka next year. Because all it is 8 squared is 64, and 8 times 2 is 16. That's how you get 16 and 64. Ooh. Both x squareds cancel. Hooray, math. Move all the numbers to one side. Subtract 64 from both sides. 80. Divide both sides by 16. So 5 is the radius. So how long is the hypotenuse? 13. So you have a 5, 12, 13 right triangle, which is a very common Pythagorean triple, which is those lazy teacher questions, so you get whole numbers. Oh, I get it. Ooh. What? I think there's only one more after this. There we go. Okay. One more. Where's the right angle? Use math words to describe it. Oh. Between the x and the 20. Like right here?
Oh, dang.
That's between the x and the 20. What? Where the tangent touches the circle. Or you call that the point of tangency. Or where the radius meets the tangent line. Or the angle included between the x and the 20. Okay. So now that we have this right triangle, we have, how do you set it up? X squared equals. Okay, so we got x squared plus 400. Now here's the Baker cheater way. Mental math. Are you ready? Mental math. Oh my God. X squared. Double it. 12 plus 12. Square it. So x plus 12 squared is x squared plus 24 squared plus 144. So you double it to get 24, you square it to get 144. That's how you mental math it. It only works when you do x plus 12 squared times itself. Step 1, everyone's favorite step. Cancel out the x squared. Nobody needs them. Subtract 144 from both sides. Huh? What?
That's wrong.
256 equals 24x. Divide both sides by 24. It's like 13 point. 10.6 repeating. So what is 10.6 repeating?
Right.
Yes. And the radius, by its thug name, the radius. Okay? Bless you. All right, last one. How big is the question mark in degrees? No smart answers here. Huh? How big is this angle? Don't be guessing. It is an acute angle, 63. How big is this angle right here? How big is this angle right here? How many degrees are in every quadrilateral in geometry? Oh. 360 degrees inside every quadrilateral. So if you do 360 degrees inside every quadrilateral and you subtract 117, you subtract 90, and you subtract 90, it should give you how many degrees are left over for that one missing angle. Most of you guys will add all of these together and then subtract them. Code was right. 63 degrees, which can also be found by taking this number and subtracting that from 180. We didn't say that, so I didn't do it. That's it. That's all the magic. That's all the love I have today. So take whatever time left to work on that. Tomorrow we'll get into chords and arcs. Okay, so now I have to distinguish between what is a tangent line, what is a chord, what is an arc. I'll give you guys the rest of the period to work on that stuff. I'm picking this up on Friday. Friday,